Okay, so previously we talked about arithmetic sequences, and now we're going to talk about geometric sequences. So a geometric sequence is, another list of numbers, except I'm not adding. So here, 2, 4, 6, sorry, 2, 4, 6, 2, 4, 8, 16. Well, I'm adding 2 to the first one, I'm adding 4 to the next one, I'm adding 8 to the next one. So I'm adding different amounts, so it can't be an arithmetic sequence. However, if I look at each term, what I'm actually doing is multiplying the preceding value by 2. So I'm multiplying each value by 2. When we have that multiplication, that's a geometric sequence. And we call that multiplication the ratio, the common ratio. So here's the general form, and so we multiply by r, which is the common ratio. And so here, notice just like the arithmetic sequences, I have a subscript, but these are all the a sub 1. So a sub 1, a sub 1, a sub 1, a sub 1. But what's changing is I'm multiplying each time by r. So I have my initial term, a sub 1, my first term, and then I multiply that by r. And then I multiply that by r. But if I already have an r, what's r times r? R squared. And if I have that and multiply this by r, I still have my a sub 1, but I have r squared times r, which is r to the third. And I have this for n times. So there's still n terms in here. So I'm going to have a sub 1 times r to the n minus 1. And that's because this first term doesn't actually have an n value. Or sorry, it doesn't have an r. So that's why I get r to the n minus 1. Right? Like if I, for example, ignore this, I have a sequence that's only 4 terms. Notice my last exponent is 3. That's 4 minus 1. So one way to help out. Okay. And our general form is going to be this. So the a sub nth term is going to be the first term times r to the n minus 1. So if we have this sequence here, 2, 8, 32, 124, 512, we know it's not arithmetic because we're not adding something to each time. So what we need to do is we need to figure out what that common ratio is. So what are we multiplying by each time? Well, 2 times 4 is 8, 8 times 4 is 32, 32 times 4 is 128. So the common ratio is going to be 4. And then a sub n is going to be equal to the first term, which is 2, times that common ratio of 4 to the n minus 1. Is that the same as 8 to the n minus 1? No, it is not. That is not the same. Why is that not the same? Because that means we multiply before we take care of the exponent. We need to do PEMDAS. We need to do order of operations. So here, I'm just going to make a note. This is not 8 to the n minus 1. We cannot do that. So we actually just leave it like this, and that's it. That is our equation. So let's say I wanted to find the third term. Okay, well that's a sub 3, and that is 2 times 4 to the 3 minus 1. So that's 2 times 3 minus 1 is 2, so 4 squared is 16. So a sub 3 is equal to 32, and yeah, it is. Look at that. Then here, I'm given the equation. Notice this is not 15 to the n minus 1. It's 5 times 3 to the n minus 1. So this sequence starts off with a 5 because this is a sub 1. And the common ratio is 3. That's what I'm multiplying by each time. So it's 5, 15, 75, and so on and so forth. Oh, sorry. not 75. I multiply by 3, so this is 55. 45. So I need to have my afternoon tea because I can't do math right now. Now, we could check this too, right? So we could say, all right, well, what's the third term here? So a sub 3 is 5 times 3 to the 3 minus 1. So this is going to be 5 times 3 squared. 3 squared is 9. 9 times 5 is 45. Bingo, we have our third term. So, you know, we don't need to work this out for each term. If we realize, all right, this is the first term, this is the common ratio, you know, what I'm multiplying by each time. So that's good. And then we also have finite sums. So just like we did for arithmetic sequences, this is actually a different formula than it is for arithmetic sequences. So make sure you don't confuse the two. So here we have these different values, and we want to find the sum of them. Again, here, yeah, we could probably just add these all up in a calculator. But let's say I'm only given the first term and the last term, and I'm told that there are 300 terms. Well, then, yeah, we're gonna need to know this formula. So how many are there? So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 terms. So S sub 8 is equal to A sub 1, which is the first one, first term, 2, times 1 minus the rate. Well, what am I multiplying by each time? 2. Right? 4 times 2 is 8. 8 times 2 is 16. So this is 2 to the 8th over 1 minus 2. So the sum here is equal to 2 times 1 minus 2 to the 8th over negative 1. Well, what is 2 to the 8th? So probably might need a calculator for that. So 2 to the 8th is 256. And then we could say, all right, well, that's 2 times 1 minus 256 is negative 255, divided by negative 1 is positive 255. So it means that S sub 8 is going to be 255 times 2, which is 510. Now, like I said, it's probably just easier just to type these into a calculator, but we do need to know that formula because you know, we're not necessarily always given the full sequence. So bear that in mind. So just like arithmetic sequences, we have how to find a sequence, how to find the formula of the sequence, and then how to find a finite sum of the sequence. So make sure you know how to do all three. And that's going to be it for the material on the first exam, your midterm exam.